Good morning, ladies and gentlemen, my dear friends. And first of all, I want to thank Professor John for having me here today. I'm very delighted to have this opportunity to unfold some thoughts and ideas with all of you. My talk today is A World in an Origami Flower. I think most of you have done some origami before, such as paper planes, cranes, stars, jumping frogs, and fortune tellers, also called cookie catchers or north, south, east, and west. And to be honest, I folded all these things when I was a little kid, and my favorite was origami flowers. In many cultures, flowers portray love, joy, and all the other positive emotions. So, at the beginning of my talk, I like to fold a classic origami flower to express my best wishes. And this origami flower is called a twisty rose. And we need a piece of square. The first step, fold and unfold along its diagonals. Step 2, fold and unfold along the middle lines. The next step, we need to fold along the creases that we just made and create a smaller square like this. And this step is called a preliminary fold. And after this step, we will get a preliminary base, just like the step 4. Step 5, we need to fold the left and right corners in half and unfold. Step 6, open the first flap and fold along the creases that we just made. Then flatten the model and we will get a shape like this. And this step is called a petal fold. Yes, to create a petal. And we need to repeat this step on the other side. Then we will get this rhombus. This rhombus is called a bird base or a crane base. Then step 8, we need to fold the left flap to the right side and repeat action on the other side. In step 9, we just need to fold a small corner on the top of the middle flap. And then we can get a simple paper crane like this. And the twisty rose is folded from this paper crane. So we need to move on. Now let's go back to step 9. We need to mountain fold this crease to this angular bisector, and we need to repeat this step on the other 3 flaps. Then we will get a flower shape with a spiral in the middle, and the last step is to shape its 4 petals. Then we will get a twisty rose. Not so complicated, right? And this flower is what origami used to be. But today, origami has become something else. It's become an art form and a branch of science. Out of the vast cloud of origami possibilities, I will try to illustrate the diversity of the art form from 4 aspects. 1 is about origami development, and 2 is about its types and laws. 3 is about its applications, and the last one is about its cultural values. So, let's begin with the development of origami. And actually, the word origami originates from 2 Japanese words. Ori means folding and kami means paper. From these 2 words, origami can be simply defined as the practice of folding paper. In some dictionaries, origami refers in particular to the Japanese art form of folding paper into representational shapes like flowers and animals. Most origami is folded from a square, with no cuts or tears. Although origami is associated with Japanese culture, its origins can also be traced to some parts of China and Europe. Many studies claim its roots may be in China, where paper was invented during the Western Han Dynasty. And Chinese traditions included the burning of folded paper shaped like gold nuggets or yuanbao at funerals. And this practice is traceable all the way back to the Song Dynasty. In Japan, folded paper designs were primarily used in Shinto rituals and ceremonies. Europe was a little different, with paper folding having origins from folding napkins, which thrived during the 17th and 18th centuries. After this period, napkin folding declined, but the tradition lived on. In the 20th century, Japanese artist Akira Yoshirawa came along. He created tens of thousands of origami models, but more importantly, he created a universal language, a diagramming system, or a picture-based set of instructions, and this language has globally promoted the spread of origami and the collaboration between artists and scientists. People from all backgrounds, for example, can learn how to fold all kinds of flowers in this language without an origami teacher like me. In the 21st century, physicist and origami artist Robert J. Lang raised the art form to a new level. Dr. Lang worked at NASA for 13 years studying lasers. In 2001, he quit his job to focus on his one true passion, origami. He studied the mathematics of origami and used computers to study the theories behind origami, and he's made great advances in making real-world applications of origami to engineering problems. His folding designs have been incorporated into many things from spacecraft to airbags. In 2018, I was honored to work with him as a judge for the Superbrain, a competitive reality show on Jiangsu Satellite TV. Bringing the tools of mathematics into origami enables artists to create something beautiful and unexpected. Last year, I set a new Guinness World Record, the most origami flowers made from a single sheet of paper. I created this origami model, the deer with 100 flowers, from a huge uncut square. It shows where we've gone in the modern world, naturalism and detail. If we look close, each origami flower on its antlers is the same as the twisty rose that we just folded. That's so amazing. Today, although origami is a minor art form in China, it's attracted more and more young artists. For instance, in the International Origami Internet Olympiad, also known as the Origami Olympic Games, the number of Chinese semi-finalists increased from 13 in 2011 to 200 in 2021. The 2023 edition is ongoing. If you are interested in origami, you can take up the challenge of entering the event. The second part is origami types and laws. In brief, we have two different origami, 2D origami and 3D origami. This is 2D and this is 3D. But how about this one and this one? Actually, they're both 2D origami. So, how to distinguish between the two origami types? To answer this question, we need to know crease patterns. A crease pattern is an origami diagram that consists of all or most of the creases in the final model rendered into one image. If we unfold the paper crane and the twisty rose, we will get two crease patterns, and they're easy to understand because only two types of creases or folds exist. The upward folds are called mountain folds, while the downward folds are valley folds. I use red lines and blue lines to respectively represent the two kinds of folds. And generally speaking, 2D origami has to obey 4 laws, and they are very simple, easy to understand. The first law is two-colorability. You can color any 2D origami crease pattern with just 2 colors without ever having the same color meeting. And the second law is based on Maekawa's theory. The directions of the folds are any vertex. The number of mountain folds, the number of valley folds always differs by 2 more or 2 less. And the third law is based on Kawasaki's theory. If you look at the angles around the fold and number the angles in a circle, all the even-numbered angles add up to a straight line, all the odd-numbered angles add up to a straight line. And the last law is that if you look at how the layers stack, you will find that no matter how you stack folds and sheets, a sheet can never penetrate a fold. That's 4 simple laws. That's all you need in 2D origami. Now we can find that the paper crane is 2D, while the twisty rose is 3D. In the origami world, most designs are 2D, following the 4 basic laws. Some 2D models may look like 3D, just because of the artistic shaping processes. On the other hand, origami can also be classified according to folding techniques. You can find almost all kinds of origami in the IOIO, such as tessellations, corrugations, kusudamas, etc. And the third part is about origami applications. Just as Dr. Lang said in an interview, One of the most important attributes of origami is, once we've studied and understood the way paper folds and unfolds, we can apply those patterns to things that are very different from paper. Over the years, origami techniques have been applied to many fields of science and engineering, leading to a range of practical applications and inventions. Here are a few examples. Medical implants. Origami techniques have been used to develop medical implants that can be folded into a small size for minimally invasive surgeries. For instance, one kind of origami heart stents can fold up to a tiny size and then unfold to open clogged arteries. Solar panels. Origami techniques have been applied to the design of solar panels, enabling them to be folded and unfolded to save space during transportation and installation. The mural fold is a well-known example. When I was 10, I folded a similar solar panel model and I remade it with an 81 square meter sheet to simulate its unfolding process in space at Forward to the Future, a science show on China Central Television in 2018. If you have any interest, you can have a try. Origami techniques have also been used to design robots that can fold and unfold into different shapes and sizes, allowing them to navigate through tight spaces and perform complex tasks. In 2016, researchers at the Massachusetts Institute of Technology, the University of Sheffield, and the Tokyo Institute of Technology demonstrated that a tiny origami robot can unfold from a swallowed capsule and remove a button battery stuck to the wall of a simulated stomach. Origami techniques have been used in architecture to design buildings that can change shape and adapt to different environments. For instance, the mural fold has also been used in the design of collapsible shelters for disaster relief. Besides, origami techniques can also be used in the micro level. In 2019, scientists from the Chinese Academy of Sciences applied origami to atomic scale. They managed to precisely fold graphene, an atom-thick sheet of carbon, into customized shapes which could eventually pave the way for new powerful computer processors. Moreover, on the website of the China National Intellectual Property Administration, we can find thousands of origami-inspired patterns for scientific inventions, utility models, and industrial designs. These are just a few examples of the many practical applications and inventions based on origami techniques. From paper flowers to space telescopes, the ancient art is now reviewed like never before. As origami continues to evolve and inspire new ideas, it is likely that we will see even more innovative applications in the future. And the last part is cultural values of origami. The simple act of folding paper can promote mutual respect and understanding between different cultures. For instance, the Japanese paper cranes and Sadako Sasashi's story have resonated with many people and opened up a whole array of social studies. In addition, Israeli artist Mira Golan has used origami as a tool for Israeli and Palestinian children to learn about each other as equals. Another example is my origami design, Zijing grass. It's often folded on the National Memorial Day on December 13th and the eve of Qingming Festival to pay tribute to the victims of Nanjing Massacre in 1937 and pray for peace all over the world. The original Zijing grass models are in the permanent collection of the Memorial Hall of the victims in Nanjing Massacre by Japanese invaders. And this is a story of Zijing grass. In 1937, a Japanese army doctor named Yamaguchi Sentailo was deployed to Nanjing, East China's Jiangsu province. When he left the ruined city in 1939, he collected a handful of seeds of the local purple flower blossoming at the foot of Zijing Mountain and brought them back to Japan. He named the flower Zijing grass, also known as Chinese violet cress and February orchid. Yamaguchi sent the seeds as gifts to friends and family members and suggested them to plant the seeds in their backyards. In over 2 decades, every year he would take a train and threw the seeds out of window in hopes of letting these little flowers bloom across Japan. At the 1985 World Horticultural Exposition in Tsukuba, Japan, The doctor's son donated 1 million seeds and told his father's story to visitors from worldwide. Since then, the flower has been dubbed the flower of peace. In 2019, I taught some messengers of peace folding origami Zijingrass, including Christoph Reinhardt and Stephen Brandy. Reinhardt is a great-grandson of German businessman John Raab, often described as China's Oscar Schindler. Over the past 30 years, the Reinhardt family has fostered 36 children and accommodated about 1,500 refugees fleeing to Berlin. Brandy is a relative US doctor, Richard Freeman Brandy, who helped set up a protection zone during the Nanjing massacre. After the class, these messengers of peace were moved by the story behind Zijingrass and brought its folding method and story to their motherlands. So far, many peace lovers from over 20 countries have learned how to fold Zijingrass. This year, the origami flower was selected as a first task at the IOIO. So if you are interested in this origami flower, you can find its tutorial on the internet. To see a world in a flower and a Buddha in a leaf is a well-known Buddhist philosophy. It explains how a diverse and complex world may be discovered through a simple object like a flower. A flower contains a wide range of information and connotation. It can be a bloom on a plant, a traditional origami twisty rose, a detail of a modern origami artwork, a solar panel that unfolds in space, and a flower of peace that sends a message to the world. So, let's see a world in a flower. Thank you.